Okay, so this is a great honor to be here and to talk to you. It's actually really fun to just be here in Serbia. It's my first time visiting this country, and already I'm having an excellent time and hope to have several more days of excellent time here. I'm going to talk to you today about innovation and entrepreneurship, and really the melding of those two ideas and how you really drive entrepreneurship with innovation. There is different types of entrepreneurs, different types of companies that people start, and I'm really focused on this idea of using intellectual property and innovation towards that. Actually, I'm also a photographer, so this was a shot I did about a year and a half ago in Slovenia, and if anybody has any great ideas for interesting places to shoot in this area, let me know after and during the conference. So what I'm going to talk to you about today is I'm really just going to go through some of the examples that I've had from my own career and how they sort of inform my ideas about entrepreneurship, about innovation. And a lot of it actually came after. A lot of time you just do things because it seems like the right thing to do at the time, but then looking back, it sort of puts all the pieces together and say, ah, yes, there was actually really a science to all this thing, and it wasn't all by accident I did it. Though in truth it was more by accident. But before I jump into all that, I just wanted to get a little bit better idea of all of you, exactly what kind of things, what kind of areas you're in, field. You know, I know generally what all this group is, but maybe more specifically, like how many people here are involved with companies doing software development? Okay, so we've got lots of software developed people. And hardware, like actual physical hardware, a few people, not as many. In terms of what kind of interaction you have with other companies, is there a lot of people here that are doing business-to-business services or like providing software development for other companies, outsourced type of software development, or consult? Yeah, there's a lot of people there. And consulting services. Consulting services, yeah, okay. Oh yeah, quite a few consulting people. And then in terms of, let's see, academia or government, the type of thing, yeah, a few people for that. So we've got a pretty broad spectrum of type of thing. Product companies, really, companies that are really building a physical product, that's their own product. A couple of people there. Good. So maybe this is a too general question to ask out of everybody here. I'd like to get an idea of like where you'd like to be. Like it's looking forward in the next year to say 5 years from your company or the company you're involved with. What do you really want? I mean, what is the biggest goal I think you would see? And maybe I'll give you a few choices. Like, is stability, just like being alive for another 5 years. Is that anybody's ultimate goal? Nobody just wants to be alive. Everybody's just happy to fold in a couple of years. Okay. How about growth? Getting bigger and changes. Just a couple of things. A couple of growth. Oh, getting more and more growth. Okay. And then how about in terms of strategic direction, like changing the type of company? I know I've seen it quite often in companies that I've worked with in the US. You often have consulting companies or services companies that are providing for other companies that want to make a transition to something that is more of a product-based company where they can increase their value and make the whole company worth more as an enterprise. Does anybody feel like they're in that category, that they'd like to find ways to make their company into sort of a different type of company that has higher value or ultimately have higher exits? I mean, actually that's the thing we talk about a lot in Silicon Valley is just exit value, is how do you make your company worth a lot at the time that you're going to get out of it, or sell it, get acquired, things like that. Okay, so we've got different feel of things. As we go on through my talk, and I'll have some time for questions at the end. Afterwards, we have the unconference section, which will also be a really good time to sort of continue a bit more interaction between everybody, get feelings of what people want and what people need and how that works. So I'm going to jump into my history. And actually, when I was putting this together, I realized that my exposure to entrepreneurship actually came before I had ever thought about entrepreneurship. And it actually came with, is this clicker going to work? There we go. So my first job. And my first job was working for my father. So he's the fourth generation of a line of chimney builders. bricklayers. So his great-grandfather was a bricklayer in England. They came over to Canada. His grandfather was a bricklayer. His father was a bricklayer. And he was a bricklayer. And it's just the way you do things. You follow down that tradition. But he decided he wanted to start his own company. Instead of working as a bricklayer for other people, he wanted to be an entrepreneur. And the main reasons for that are pretty common in terms of any entrepreneurial enterprise. The number one reason, it is not money, but it's more of just freedom, ability to do what you want to do, when you want to do it, and not be at somebody else's mercy. And the number two reason is money. So you can make more by working out on your own. Now, I would call what he was doing and what, it may seem very different, being an IT company, being a software development company, or a other types of information technology is far away from a carpenter, a plumber, a bricklayer. But really, there's a lot of similarities between this type of entrepreneurship and any other type. He had the same kind of issues. When he started this company, it was great. He has 0 employees. He's basically a one-man operation. He goes out and he makes a good amount of revenue from people because he has the skills needed, and he can do a good job, and he can satisfy his clients. But eventually he wants to grow and get 1 employee. And that actually helps. You have a helper to go out, you can make more money, you can do more, and that's great. And say, well, let's do more. Let's make this a big company, a giant 2-person enterprise, a 2-employee enterprise. And already the problems are starting. It's like the next employee and the revenue doesn't really go up, and the profit goes down, actually. And it's because the company's all based on his own personal skill. And as soon as it gets beyond the place where he's actually doing the work and the primary player in that it really doesn't scale very much. And then you get the 3rd employee, and things even go worse. It goes downhill. And he never got out of this. He always, through his career, he just had 1 or 2 people working for him. And often, up until the time I was going to college, I was one of those people too, learning how to be a bricklayer. And that was the expectation, that I would be a bricklayer and carry on the family tradition. But instead, I went to college, studied electrical engineering, computer science, went on to graduate school, and learned a completely different field. When I graduated, I started off my work career, other than this, at Bell Labs in New Jersey. And that was a great place to learn about innovation and invention and how it's done on a large scale, on a corporate scale. Now, Bell Labs, at the time and prior to that, was the research arm of AT&T. And it was a monopoly. I mean, they were the phone company of the US, and they had pretty much could set their prices within some government controls. But they had a huge amount of revenue and a huge amount of budget. Like, I think it was the highest in the US as percentage of their budget they were spending for research. So they could fund this large research organization. I'm getting kind of a buzz here. Is the AV got some issue with buzzing? Or no, there's nobody there now. If we could figure out why that buzzes so much, it might probably be better. So, so Bell Labs is a great place for innovation. I went there to work on acoustics research, actually, audio research for communication. So I was working on the early GSM coders for speech coding. So I was trying to do compression of speech. Now my clicker's not doing something here. There it goes. I was working actually on so speech coding, also on music coding of the early MPEG coders. This is the picture on the right is a picture inside Bell Labs of the what was known as the quietest room in the world, or the quietest place in the world, a large anechoic chamber, where I was doing some of the work on how people hear things. And it was an interesting lesson. It was my first real lesson in thinking about how you do true innovation. The issue that Bell Labs was facing was how to do compression of audio, how to make speech coders compress audio so you could build the cellular network out, really, and scale up the cellular network. People had been looking at how you do compression and thought of the problem in one particular mindset. That is, can you compress audio down to a lower bit rate and still recover it without any distortion? And it was the same thing going on with music encoding at the same time too. Can you compress it without distortion? The real innovative leap was realizing that it wasn't really getting rid of distortion that was important. It was making it so people couldn't hear the distortion. You could distort the sound all you wanted as long as people couldn't hear the difference. And so I spent a lot of time focused on hearing perception, about how people could hear sound and then how that tied into the compression. And ultimately it was quite successful in terms of coming up with the low bit rate speech coders that are used in GSM, and then also MPEG, which then became MP3s and all of that history. The other thing I learned while at Bell Labs is a little bit about, I don't really have any formal training in product design, but I learned a lot about how you can drive a new product into the market in terms of need. And what I call that is sort of feeling the need. There it is, feel the need. So if you are doing something where I'm having a little bit, maybe I should just rotate this a little bit so then it's picking up the click a little bit better. When there's something you need yourself, something you feel that it would make your life better or make you more efficient or work better, and you develop a product based on that, it generally turns out to be a pretty useful product because you know at least one person really needed it, and you as the engineer or developer or basically the person designing that product, the entrepreneur, have a lot of flexibility in making it serve your own needs. What happens a lot more is people try and start companies and do things imagining what other people's needs are. And sometimes that works, but generally, when you try and imagine what somebody else needs, you're usually off target. You usually think they need something that they don't really, or you miss the things that they really do need. It's sort of like when you give a gift to somebody. If you're giving a gift and you don't really know what they want or need, you sort of imagine, oh, well, they'd like this. This little object here, I don't like it. I think it's really ugly, but I'm sure they'll like it. And that usually fails. It's like, it was ugly, nobody likes it. When you give them a gift of something you like yourself, that generally works better. So I always take the idea that you'll give gifts of things you would like to have yourself, and you're safer that way. Because doing this, imagining what others' needs, really often fails. Now the other approach would be to ask users what they need or what they want and try and elicit things from them. And the problem with that approach is that users miss disruptive changes. They see evolution. They say, oh, what I really need is for this particular thing to go a little bit faster or to be a little bit easier to use or something like that. What they don't see is that there's a whole nother possibility, a whole nother way of solving their problem that they're not seeing. And that's sort of the disruptive change. And users are generally not very good at seeing the disruptive change opportunities. And that's why, if you're somebody that's thinking about things in a way that allows you to make leaps, and you're the one that needs something, they really work together really well to allow you to make disruptive new products. So when I was at Bell Labs, what I found was we had a need. And I personally had the need. It was for audio. I was doing all this work with audio, trying to understand how people hear. And there was no really good way of getting audio in or out of a computer at the time. There was some really inexpensive sound cards for PC level computers, but for workstations, for Unix workstations, and even for PCs for doing high quality, nothing existed out there. So I set off and started a company from there. My first company, which was Townsend Computer Tools, which was building a piece of hardware, a signal processing audio interface. And this was basically a device that had processors in it and a digital signal processor in it, and would interface to Unix workstations or other computers or even Macs, and allow you to do high quality audio. Now the nice thing about this, well, there was a few interesting things about this. I mean, the product itself was interesting to me. It's not earth-shattering type of product. It's something, it does what it's supposed to do. But it was interesting from the point of view of the company as well, of how you start a company. This is the, and we'll probably hear more about this kind of picture of startups. This is really the classic Silicon Valley type startup evolution. You start off at some time, you take some investment from, it's kind of hard to read there, it's kind of small on the screen right here. The first little section there is sort of the seed capital. You get money from your friends. The founders put in money. You get some initial angel investors to put in money. And you start developing a product. You burn some of that revenue. The graph on the y-axis is showing the cumulative revenue you've had from the time you started until the current time. So your total revenue, your cumulative revenue is going down, becoming negative for a while, and that's what's called the valley of death. Don't know it's negative. The valley of death gets too big, you run out of money, and that's it. Hopefully you get through the valley of death, you start selling a product, it comes back on the upswing, you get some positive revenue, and then you go through these first round, second round, third round of venture capital financing, you do mezzanine financing, you either have the companies acquired, you do an IPO, and things keep looking great, unless you're Facebook, in which things just like, that's it, that goes down after. So this is sort of the classic approach. The approach that I was taking is pretty different. What I was looking at is more of the approach that the small entrepreneur would take of, you know, the chimney builder or the plumber. And that's a bootstrap sort of model. You start off and you never go negative, and you never take outside capital. So in this company, I didn't take any investment, and I had the advantage that, you know, this product was something that I knew I needed at Bell Labs, and other people needed at Bell Labs. In fact, Bell Labs wanted it so much that they ordered the first batch of product from me before I even left Bell Labs. So I had the first order from them, and they paid for them in advance as well, because they wanted me to build the company to make the product, which then they could buy. So so I basically collected that first sale on day one, and then that was the money that was used to do actually the product development and design it and get it built, and then delivered that product to them, and then continued delivering it to other people. So that was, maybe it was a special situation in terms of being able to bootstrap the whole thing, but ever since I've always tried to avoid taking too much money. I mean, a lot of times people want to get big investments of venture capital or other investors involved in the company. And the thing about that is, if you raise a little bit of money, the bar for success is here. You know, you have to do better than that and be able to return the money. If you raise a lot of money, you have to do a lot to make that a successful company. You know, you're almost, if you raise too much money or too high a valuation, it's almost dooming yourself to be a failure, because it's almost impossible to ever recover that and get enough of a multiplier that people think that that's actually a success. So that was that company, but the problem with that company was building hardware is actually kind of hard. It's like you have to actually have physical thing you're doing. You have to get subcontractors. You have to have other people building things. You have to deliver. You have to do maintenance. You have to do shipping. It's like it was a little bit more headaches than I wanted. So the next venture that I jumped into, I had a friend back in California that was involved with a linguist involved in language testing, about how you measure how people speak different languages. And he also had a career in speech recognition as well, as I did also. When I was at Bell Labs, I was also tangentially involved in speech recognition. So we got together and started a company that was different from the existing companies. The existing language testing market was a very traditional type of market. It was testing people of how well they speak. So many of you may be familiar with the TOEFL exam, for example, the test of English as a foreign language that's given in many English-speaking universities for graduate studies or studying in English language environments. So you have this written type of test, multiple choice test, and you have spoken language tests, which are generally sitting down with somebody or recording your voice on something and having a human listen to it. So what Ordnet did was to take speech recognition technology and build an automated system that could listen to somebody's voice and figure out how well they speak English at first, and then other languages as well. And the way it did that was looking at the person's voice and looking at many samples. We had hundreds of thousands of transcriptions of actual people saying different things, and had human raters listen to them and judge their ability to speak the language. And so then we had this big validation database, and then you do speech recognition on that, figure out where it is that people are saying different things, and align that together and come up with a judgment of that person's ability to speak. And we're measuring not only what they say, so did they give there was questions There was tasks asking them to repeat things, different types of tasks like that. So we're measuring that they actually understand the question. Were they able to repeat the sentence? So they actually were able to generate the language. And also how well could they pronounce it? How well could they even conjugate it? Because if you give somebody a long sentence to repeat, they can't really remember every detail of the words. They sort of had to remember the whole idea and regenerate it with the correct pieces, the correct grammar. So. Oh yeah, so I just wanted to talk a little bit about, when I was putting this together, I was also thinking about the different ideas of innovation and how you sort of segregate innovations in different classes. One of them ways of sort of dicing it up is to think about innovation in terms of internal innovations, internal to the company, I would say. So it's like things you do to make the company more efficient, to make it more competitive, to make it able to compete at lower cost with other companies in the field. And this is sort of what AT&T Bell Labs was primarily interested in, is they were the phone company. They were delivering telecommunications. It's not like they were going into other business. They were tangentially, but primarily they were the phone company. And what they were doing research about was how to lower the costs of doing that, how to improve the quality. So it's really, in many ways, these were internal innovations that are not seen by the outside public other than just a better service, but not really as a different type of product. And then obviously the other type is the externally visible ones. The things that are actually, the innovation is what somebody is buying. So the use it, the internal one, and the sell it, which I would say like Ordinate, the language testing was a sell it type of innovation. It was actually providing qualitatively different type of product, because before what would take a long time period to get graded, it would take investing a time into visiting a rater, could then be done over the telephone in 10 minutes, and you get an immediate score report. The way those work in terms of how this drives margin, how this drives revenue, if you look at a scale along the X here of innovation level, and this is all qualitative. I mean, all of the graphs and things that maybe look sort of quantitative in this are really qualitative ideas, because different companies are different industries are different, the numbers all change. And I'm not really going to define what I mean by a measure of innovation along the bottom. But just to say on the left, you've got companies that are traditional companies in a market, and they have some margin, and that margin is driven really by competitive pressure. It's like you've got 50 other companies that are doing that too, and the amount you can charge your customers is really based on what everybody else is charging and how much you can make out of that. When you start to incorporate sort of innovative processes in a company, change the way you're doing things, you can reduce your cost, you can make the whole operation more efficient, and you can increase margin that way. But you're still driven by the competitive pressures. It's just that you're able to get a higher margin out of the whole industry than somebody else that's not using these type of processes. When you move into innovative products, you're not so much, well, maybe I should say call them more unique products and services. You're moving more towards being a monopoly in the business, because you're the one that's providing something that nobody else is providing. And despite everybody that talks about anti-competitive behaviors and things like this, monopolies are really good things for the people that have them. The best kind of company to own is one that's got a monopoly on something, because then your pricing is all driven by what people are willing to pay for what you have. What value are you giving to them, as opposed to what everybody else is doing. And that's all great, but can you go any further? And the answer is yeah, I think you can. And you can get way out here in the top right corner. And that's where the thing you're selling is the innovation. So the difference here is that that middle triangle was you have an innovative product, and you're selling this product that incorporates certain innovations. But you can also go all the way and just sell the innovation. And I'll talk more about what that means. This is sort of a classic look at value chain, Michael Porter from like 85 and onward, of how different elements of a company contribute to make the margin of the thing. On the bottom half is all the direct costs and things you might be involved with. On the top is indirect. So you've got things like all the operations, and on the bottom, and sales and marketing, service. And as I mentioned before, my first company, I was there's lots of headaches in doing all these things. And so I've always been trying to sort of eliminate some of these things. And so what I looked at then, I said, well, let's get rid of all this stuff that actually is to making your product and not do any of that. In fact, not do most of anything here and just focus just on even the firm infrastructure to try to get rid of. Just focus on technology only. And obviously, if you could just do that, you can increase your margin a lot more because you're just selling the thing that you're the best at, the actual developing the technology. And also, the other side to that, it's also a lot more fun, I find. It's just to focus on the technology side of things. So I started another company with no products, no services, just an invention, leveraging the IP, and that was really developed the 56K modem, which was a modem, the sort of the last of the line of voice band modems, regular dial-up telephone modems. And it was actually interesting because when I was doing this sort of trying for the IP companies, I was looking at different ideas and had a number of different projects that I was working on. This one came out of the idea of music, really. So what I was trying to do was build music on demand. So build a system where you can listen to any piece of music you want in real time and just choose it and play it. Sounds a lot like, you know, what Napster eventually did, what iTunes has, what Spotify and Mog and all these other services are delivering now. But this was before the web. This was prior to the time that the general public was using the internet and using the web. So we're talking about, you know, the 1993 time frame, 92. So before the first browsers were really out there. So the way I was thinking of doing that was thinking of a home stereo appliance where you're basically, instead of having it playing a CD or something, you would connect it to a dial-up telephone line and you'd have a remote control where you just choose your piece of music and it talks to a server and downloads that. The problem was that the music compression, and this is what I'd been working on before, and the people that I had known at Bell Labs that were doing music compression, I continued in contact with, they could get music down to like 60 kilobits a second. On the voice band modems, dial-up modems, you could get to 33 kilobits per second. And so we worked a lot on trying to lower the music data rates. But the problem is the quality degraded really quickly. So then I looked at, well, if I can't get the music compressed more, can I get the data through faster? And Bell Labs actually helped in the sense that they had been, while this is all going on, they've been changing the telephone network. Modems had always been designed to be symmetric things. You talk from one dial-up connection to another dial-up connection over an analog line. That's what they were originally designed for. That was what the telephone network was doing. But in the meantime, the telephone network had changed. Internally, the telephone network had become a digital place. Everything was carried digitally between central offices. It was only the last kilometer or so from the last central office to a person's home that was carried analog anymore. The other thing was you could get a server that was connected digitally up. And this is a pretty common pattern now. But at the time, people weren't even realizing what this means. And so for the music program, I was thinking, well, I could hook up my server digitally to the network. It only has to go one way, sending digital down to the client. So I only really needed to, I can't really point at this, but over there at the right side, I only really needed to have a modem that handled that local loop at the end, and everything else could carry digitally. And as soon as the problem was reformulated like that, there was actually a pretty straightforward solution to how to design the protocols and everything so you could get the data through at almost 64 kilobits a second, and that enabled that whole possibility of doing that music on demand. Though I never did the music on demand because that was the same time that the web started taking off. The first Mosaic browsers were out there, and people were starting to use it. And this was exactly what they needed for that as well. They needed to get web pages downloaded quickly. And they didn't really care about the upstream because it was only keystrokes and things like that. So the modem became really the valuable commodity at that time. And I didn't really need to work on the music anymore. It would have been fun to do it then. And now, in retrospect, it would have been fun to build the music program as well. But this was easier in many ways. It was easier also in the sense that I didn't want to then jump into the modem business. There was all these companies that were in the modem business. They have, billions of dollars worth of sales per year. Large companies that were very aggressive. They were competing very aggressively. I didn't want to start trying to jump into that, because that would require a whole new skill set that I didn't have in terms of making all this type of production efficient and doing these. So instead, what I did is I just licensed the technology to everybody. And they had, once one of them had it, everybody had to have it, because they were competing on speed. I mean, if company A's got a 33 kilobit modem and company B's got a 56 kilobit modem, company B is going to take the entire market share regardless of the pricing. Nobody's going to buy the slower one. So that worked out quite well to non-exclusively license everybody in the industry. So these, actually, this is looking at this innovation another way, innovating in how, innovating in what, sort of the product, the providing the innovation. So that's really how I think about the modem thing, is I wasn't selling a product that was innovative. I was giving or licensing everybody else an innovation which they could use then in their products, the modem. But then I was thinking about this, and I'm thinking, well, I'm up in the top right corner. It seems like a great business to be up there, but can you do any more than that? Can you actually take this innovation idea any further? And I realized that yes, you can. You can go even one more step. And now the next step we're thinking about is domains of innovation. That is, instead of looking at a particular product or a particular innovation in a system, is to say, is there a whole new field out there? Is there a whole new class of things we could do differently? And social media is a good example of, it's completely different, completely changed the way people think about things. I would say it's not just a evolution of the web or things, it's almost a revolution. Though some of the implementations are not that great. But the one that I went into, actually, was a completely different area. And this may seem a little bit far away from IT and communications, but it's actually, there's a lot of lessons that are very closely related and very, very much the same. So I started working in synthetic biology, and that field is really taking DNA from different organisms and sort of mix and matching it to build new functions in organisms. So I went back to school, actually. I went back to school for like a year and a half, retaking classes like organic chemistry, molecular biology, things like that, to sort of learn the basics of how you do this type of biological work. And the reason for it was because I was seeing the internet at the time was it was getting less interesting. This was just after the first big bubble of the internet, and it was thinking, really seems like there's biological systems really have a lot of potential. The thing about a new field was really also very interesting to me, a green field, I would say, is that anytime you start something new, start working something new, there's going to be new problems. You're going to come up with problems you're going to have to solve. And most of those problems are not that difficult to solve. Okay, so you can come up with solutions to them. The thing is, if it's a green field, there's a new thing that nobody's done before, those solutions that you come up with are the first time anybody's come up with a solution to those problems. So they become very valuable intellectual property instantly. Okay, so in that type of field, it's much easier to invent, to make innovations, because nobody's tried to do it before. And so it's a much more huge opportunity to be first to innovate, first to invent. What I'm doing more specifically there, okay, now I'm going to give you a little biology lesson here, since you didn't know you were going to come here and get some biology tutoring. But at a very simple level, what I'm doing is building switches. So I'm building switches made out of DNA that turn genes on and off. So it can turn off production of different proteins in an organism. And they do that based on whether another molecule is present. And I can do it, the idea is to do it so you can make it sensors for anything. You can detect any type of molecule and turn genes on and off. A good example is one group did a project where they made, not actually using the technology that I'm working on, but a similar type of ideas. They made a bacteria that was sensitive to nitrites. So if nitrites are present, it turned on a gene or turned off a gene. What gene they did, they then took a fluorescent protein from squid, from a giant squid, and put that together with it. So now they had this bacteria that when nitrites are present, it would glow green. So what do you do with something like that? It doesn't sound that useful. Well, it is. What you do is you spray that on fields, okay? And where there's nitrites present, the bacteria glow green. And where the nitrites present, well, if you have landmines that are leaking from TNT or dynamite, they leak a lot of nitrites into the soil. So then you've got a thing that has bacterial growth this green glow wherever there's landmines present. So obviously, that could be a pretty interesting possibilities of how you can take something like this at a bacterial level and make it into something that's like a useful type of product or system. The other thing that's useful about, interesting to look at this for, as well as the sort of the innovative aspects in terms of information technology, is this is one of the big drivers for big data now. So the kind of experiments I'm doing with this are generating petabytes of data. So it's just doing sequencing of organisms and looking at designing experiments that use some of this next generation sequencing type of work. And it's generating huge amounts of data, huge amounts of analysis requirements. You need a lot of compute power to do this. And definitely companies that are looking at that field and investing in doing information technologies for this are definitely doing well there, or hopefully will do well. So just to recap some of the things, there's sort of a couple of lessons here. One is just sort of thinking about innovation. Another way is going back to sort of my father's problem about return for employees. This is a more traditional, his company was really, and the small companies are really bad in terms of revenue per employee going down so quickly. But, and more traditionally, it's sort of like, as you build a company out, sort of the return for employee asymptotes, and you can't make it worth more than a sort of a multiplier of your number of employees. One of the things that innovation does is pushes this whole graph up. I've been focused a lot on the left side of the graph, sort of small companies. I just like the idea of building a very high value, small enterprise. But then there's also this applies also going way out there when you have large companies, and it's a one way to do the innovations. The other, I think the bigger lesson is, I think that big change is a lot easier than people realize. It's easier to make huge changes either at a personal level in terms of what you're focused on, what you're doing, or at a corporate level and changing strategic direction and changing things. It's the thinking about it that's hard. It's really hard to get over the hurdle of actually doing it. But actually, once you jump into something, I think it's actually much easier than people think to make those kind of changes. So thank you. And if there's any questions, I can do that now. Some questions, anybody? Yes?
You perhaps had the fortune of being in a situation where you the guys at Bell Labs, needed something and you make it.
Yep.
So you knew that those guys needed something and they knew that you can make it, and you made that kind of deal. Can you tell us, do you have any perhaps advice for people who would like to get to pre-orders before making the product? Because that's a pretty cool situation to be in.
Right.
You can avoid the valley of death, among other things.
Yeah, I mean, obviously, having a situation where you get pre-order something, that's kind of an extreme situation. It's not going to happen very often. I've never seen it happen again in my career after that. But on the other hand, finding the product that's needed is not that hard, really, because there's so many things that are needed out there. It's just, it's a matter of being observant and noticing what there is going on. The other thing is about ideas. I don't think I made this point, and I meant to, is for every idea, there's like hundreds of people that have thought of that idea before, okay? And really the difference of innovation from just ideas is that the innovation is really an actionable idea. It's something that you've actually taken and run with, right? So, people keep seeing the same problem over and over again, but it's the hundreds or the thousands person before they actually go and make something out of it. Because you see so often, you see somebody that comes up with something new and say, oh, I thought of that like 5 years ago. Well, yeah, you probably did, and thousands of other people thought of it 5 years ago, but you have to be the one that actually runs with it and does it. Yes?
How does Apple fit into this story? There are a lot of companies that have a great number of employees.
Yep.
They have insane profit margin, and they are giving people what they need.
Right. Yeah. No, I mean, they're a great example of a large innovative company because I think they are the one, the question was, how does Apple fit into this whole thing? They are a large company and they're giving people what they need and they're doing well at it. I think ultimately, they're keeping their product unique, really. They keep doing something that is different from what everybody else is doing. Other companies tend to emulate them and try and jump into that. They say, oh, that's a successful product, let's make some of that too. But what Apple's really doing is just being innovative. And also, I mean, the ethic of Steve Jobs in terms of focusing so much on design. People often think that this level of aesthetics and design are not important. And Apple's been disproving that people really do appreciate a beautiful product, even if it costs more, even if it's, they would think that, we can just buy the cheapest thing. But it turns out that there's a huge value in that. And that's really the market you want to serve. It's much better to serve the market that appreciates something that's a higher cost, a higher value, and a higher profit margin for you than serving a market that is completely driven by pricing pressures and everything and trying to serve that market. So it's a better place to be. Did that answer that a little bit? I mean, okay.
Thank you.
Any other questions? We'll also have time during the unconference to discuss some more of these things. And in fact, today there's a few other speakers that I'm excited to hear about too, that are involved with innovative, with iFi and with Shazam and agile development. So anyway, thank you very much and thank you.